Have you ever struggled to capture a business or software process in a way that everyone can understand? If so, I'm going to show you how activity diagrams can make it simple. So stick around. Hey, Doc Squad, Dr. White here with the Business Analysis Doctor. Before we get started, if you want more business analysis training and tips, be sure to subscribe to the channel and turn on that notification bell. Let's dive in. So, what is an activity diagram? An activity diagram is a type of UML diagram that visually represents the flow of activities within a business process or software system. It depicts the sequence of actions or steps involved in completing a task or achieving a goal. Activity diagrams are particularly useful for modeling business processes, software workflows, and system behaviors. There are three general types of activity diagrams, including a business activity diagram, a system activity diagram, or an object level activity diagram. Let's do a comparison of these activity diagrams to outline the differences between them. The first type is the business activity diagram. The purpose of this diagram is to understand the business workflows within an organization. It focuses on high-level business processes depicting interactions between departments or business units, focusing on the business rules and decision-making processes. The actors in a business activity diagram are the internal and external business stakeholders, such as employees, customers, and automated systems. The level of detail for this type of activity diagram is pretty abstract as it focuses on the overall workflow. An example of a business activity diagram might be the model for the order processing workflow. The next type is the system activity diagram. The purpose of this diagram is to document the functionalities and interactions within a software or system. System activity diagrams focus on system workflows, illustrating user interactions and internal processing. The actors here are the system components. These can be users, internal systems, subsystems, and external systems. These actors may be the same as the actors in a business activity diagram, but more focused on interactions with the software system versus the business process. The system activity diagram is more detailed than the business activity diagram, as it breaks down and narrates the specifics of the software system actions. A simple example of a system activity diagram will be a login process for an application. Now we have the object level activity diagram. An object is defined as an instance of a class that participates in the activities depicted in the diagram. Objects represents the entities involved in the workflow and their states as they progress through the activities. This activity diagram is typically used for detailed design, implementation, and testing of specific objects or classes. It focuses on the individual object or class within the system to focus on how it behaves or interacts. The actors of the object level activity diagrams are the objects and sometimes the associated classes. Activity diagrams at this level are the most detailed because they zoom in on the activities associated with individual objects or classes within the system, including method calls, message passing, and state changes. An example object level activity diagram could model the order object interacting with the customer object. Activity diagrams are useful during project management and business analysis activities for several reasons. During initial information gathering, activity diagrams can be used to document existing processes within an organization or a software system. It can also facilitate process improvement. Activity diagrams can help identify bottlenecks, redundancies, or decision points that slow down the process. This allows for brainstorming and designing improvements to streamline the workflow. During design, activity diagrams can be used to model the proposed system functionalities and workflows. This clarifies how the system will respond to user actions and interact with other components and provides a blueprint for developers to implement the solution. Define testing cases. Activity diagrams can be used to map out test scenarios by depicting the expected flows of actions and decisions within the system or process. This helps identify potential failure points and ensure comprehensive test coverage. Documentation and training. An activity diagram can be extracted from a use case description to visually depict the user interactions with the system or specific use cases. They provide a clear visual reference for stakeholders to understand complex workflows, processes, or system functionalities. They can also be used for training purposes to illustrate how the system or process works. So, who is the activity diagram for? The audience of an activity diagram can vary depending on the stage of the project and the specific context, but the primary audience typically includes business analysts, stakeholders, system analysts or software architect, and developers. Business analysts use business activity diagrams to model and analyze business processes and systems, identify areas for improvement, and document requirements. The diagrams also serve as a communication tool with stakeholders. Stakeholders, including subject matter experts, end users, and customers, may review business activity diagrams to gain a clear understanding of how the proposed system or process will function, allowing them to provide more informed feedback. This will ensure that the proposed solution meets their needs and expectations. Systems analysts and software architects use system activity diagrams to analyze, document, and communicate complex system behaviors, including user interactions, data flows, and decision points. Developers refer to system activity diagrams during implementation to understand system requirements and design, helping them to write code that aligns with the desired behaviors of the system. Alongside the software architect, the developers may use or create object activity diagrams as a detailed blueprint for implementing the behavior and interactions of individual objects or classes within the software system. Now let's look at the main components of an activity diagram. The first component is the activity groups. This is a method of grouping related actions, behaviors, or flows to provide a clearer structure. These groups help simplify complex processes by clustering without affecting the flow. Activity groups include partitions. These are containers that represent different participants or organizational units involved in a process. They're used to group and organize activities based on a participant's role, department, or system responsible for them. They also distinguish responsibilities within the process or system. They're typically depicted as vertical or horizontal columns dividing the diagram. Now, swim lanes are a visual way to represent partitions. Swim lanes and partitions are often used interchangeably. However, there's a subtle distinction. Partitions are a more abstract concept used to divide an activity diagram into sections based on logical groupings. While swim lanes are the most common approach to represent partitions, other approaches may include labeling or coloring. The next activity diagram component is behaviors. These represent the specific steps or tasks that occur within a process, illustrating how the system or actor achieves a particular outcome. The first behavior we'll discuss is an activity. An activity is a composite behavior that groups multiple actions or other activity nodes, defining a more complex set of behaviors within the system. They're depicted as large rectangles with rounded corners containing a short description of the activity. The description label should be in a verb-noun format. Now let's discuss actions. An action is an individual unit of behavior that represents a single step or task within an activity. Actions can range from simple operations such as read data to computations such as calculate customer lifetime value. Action nodes are depicted as smaller rectangles with rounded corners and is also labeled with the verb-noun format to clearly describe the action being performed. As mentioned earlier, there are usually several actions inside of one activity. Specialized actions that are commonly used are as follows. A send signal action sends a signal to another element, initiating communication or triggering some activity elsewhere. This is notated as a convex pentagon with the name of the signal placed inside of it. An example of a send signal action might be to send a payment request. The accept event action waits for a specific signal or event to occur. Once the event is received, the flow of control continues. This is notated as a concave pentagon with the name of the action placed inside. An example of accept event action might be confirm payment. The accept time event action waits for a specific amount of time or until a particular time event occurs. Once the time condition is met, the flow of control resumes. An example of accept time event action might be to wait for the cancellation window to close before shipping. Now let's discuss object elements. These are entities involved involved in the process that indicate how information flows and changes throughout the activities. Object elements can be classified as objects and data. Objects are entities that are manipulated within the process. They represent elements that are required, created, or updated by an activity. Objects can be connected to activities or handed to other objects via object flow arrows. They're depicted as rectangles containing a description of the object in the form of a noun. For example, production material. Now, data represents information that is used or produced by activities. It shows how data flows through the process. Unlike objects, which may be tangible, data is more abstract and focuses on the information itself. Data is typically represented using the same node as the object node, which is a rectangle, except the description would describe a name and the type of data between a pair of double chevrons. A common data type is a data store, which indicates a place where data is stored for later use. An example of a data store would be something like personnel data. Another data object is a central buffer, which is a temporary holding area for things that are being processed by objects within a workflow. They help manage the flow of items between different object flows, making sure they're held until they can be processed by the next object. An example of a central buffer might be an order queue that holds the orders until the order details can be processed. Now let's discuss edges. These are connective paths in an activity diagram that define the flow and illustrates the movement or transfer of control from one step to another. Common edges are control flows, object flows, and interruption flows. Control flows are lines that represent the flow of control from one activity to another. They show the sequence of activities and connections between activities. Control flow arrows are illustrated as directional solid lines with open arrowheads connecting the elements of the diagram. They can also have labels to indicate the conditions that direct their movement, such as following decisions or to describe exceptions. For example, item not available. Object flows are arrows that connect objects to actions, activities, or other objects. They indicate the direction in which data or physical objects are passed between the elements. These are also depicted as solid lines with open arrowheads connecting the elements. They're also labeled the same as control flows. The only thing to distinguish a control flow from an object flow is whether an object is attached. When the object flow points from the object to the activity, the object is required as an input to the action. When the flow points from the action toward the object is created, updated, or changed by the action. In other words, an action output. An interruption flow is a special type of flow that represents an event or condition that can abruptly terminate the execution of an activity or group of activities. It's used to model exceptions or unexpected situations that can disrupt the normal flow of a process. It's typically illustrated as a lightning bolt symbol connecting an interrupt event to an interruptible activity. For example, an interruptible event such as process payment could be inside the interruptible region here. If a cancellation comes in, this would be an exception or an interruptible event, which will lead to processing a cancellation instead. The next group of activity diagram components is control nodes. These are structural elements that manage the flow within an activity diagram, determining how and when the process moves between different behaviors based on specific conditions or events. The first control node we'll discuss is the initial node. This is the starting point of the activity diagram. There can only be one start node in an activity diagram as it marks the initiation of the workflow. It's depicted as a solid black circle. A decision is a point in the process where a choice must be made between alternative paths. It indicates a point where the flow of control can alternate based on a specific condition that ensures the flow of control only goes down one path. Decisions are represented by a diamond shape with one incoming flow and multiple outgoing flows, each representing different paths that can be taken. Each outgoing flow should be labeled with the guard or condition that must be true for the flow to continue. Each guard should be placed between brackets. Also, There is no limit to the number of outgoing flows exiting from the decision. Examples of guards for a decision that looks for errors might simply be yes or no. Merge nodes are used to connect and consolidate alternative paths. They're used to unite or reunite multiple control flows back into a single flow. Merges are depicted as diamonds with multiple incoming flows and a single outgoing control flow. Forks are bars that split a single flow of control into multiple parallel paths. They're used to represent the beginning of parallel activities. Forks are depicted as thick, solid, horizontal or vertical bars with one incoming control flow and multiple outgoing control arrows. There is no limit to the number of outgoing control flows of the fork. Joins are bars that synchronize multiple concurrent paths back into a single flow of control. They mark the end of parallel activities and ensure all branches are completed. The parallel activities can begin in any sequence. However, both flows must be complete before advancing past the join. They're depicted as thick, solid, horizontal, or vertical bars with multiple incoming control flows and a single outgoing control flow. There's no limit to the number of incoming control flows of the join. A final flow node is used to determine a specific flow within an activity without terminating the entire activity. It effectively stops the flow of control or data through a particular path, but allows other concurrent flows to continue. A flow final node is represented by a circle with a cross inside. The activity final node is the endpoint of the entire activity diagram. It marks the end of the whole workflow or process path. The activity final node is depicted as a solid circle inside another circle. It should have no outgoing control flows. There can, however, be multiple activity final nodes in an activity diagram indicating different possible endpoints. However, only the first one reached will terminate the entire activity. This means that if there are multiple paths through an activity, each ending in different activity final nodes, the first path to complete will cause the entire activity to end, even if other paths haven't finished yet. Now let's look at the steps to create an activity diagram. First, define the scope and purpose by determining what processes or system the activity diagram will represent. This includes defining the goal of the diagram and what you want to achieve or illustrate. This would also include determining the type of activity diagram. Next, identify the activities by reviewing any existing documentation or observing the process of interest. List all the key steps that occur within the process and also determine any detailed actions within each step where appropriate. Then identify actors and groups. You'll need to identify the stakeholders or systems that interact with the process. If multiple stakeholder or departments are involved, organize the activities in a logical grouping to define the swim lanes. Establish the start and end points by identifying where the process begins and where it ends. This involves determining inputs and outputs. For the inputs, identify what triggers are required for each activity to begin. For the outputs, determining what each activity produces or achieve, which may be used as inputs for subsequent activities. Also determine the sequence by establishing the order in which activities occur and how they flow from one to the next. This will also involve identifying parallel processes that require forks, joins, or merges. Next, define decision points by reviewing relevant business rules to identify points where decisions are made that affect the flow of activities. This also includes identifying any exception points or alternate flows. And lastly, review and refine. Review the diagram with subject matter experts for accuracy and completeness, and ensure all activities are connected logically and that the diagram is easy to understand. Now let's go through some best practices for creating an activity diagram. First, use consistent notation throughout the diagram. Use standard symbols for activities, decision, control flows, and other elements to ensure clarity and readability. Ensure clarity and conciseness by striving for an easy to understand diagram. Avoid excessive complexity that might obscure the workflow. Use brief but descriptive labels for activities, decisions, and guards. Confirm start and endpoints. Every activity diagram must have a single, well-defined initial node representing the workflow start. It should also have at least one final flow marking the successful completion of the process. Maintain a clear control flow between activities using arrows. Avoid crossing or connecting arrows unnecessarily. If complex routing is unavoidable, consider using a separate diagram or a layout tool. Ensure clear and concise labels for activities and use guards near decisions to specify branching conditions. Make sure that labels are understandable to stakeholders who may not be familiar with technical terminology. Consider using swim lanes to group activities for complex diagrams with multiple actors and systems. This improves readability by visually separating activities performed by different entities. And finally, maintain focus by depicting a single, well-defined workflow or process. Avoid cluttering the diagram with extraneous details that might distract from the main flow. Now let's look at an example activity diagram using an ATM transaction. Okay, so here we have three swim lanes, one for the customer, one for the ATM machine, and then one for the bank. So we're going to start with the customer inserting the card. The ATM reads the card data, then validates the ATM card. The ATM makes a decision. If the card is invalid, the ATM ejects the card. Then the customer takes the card back. And this will end the flow. If the card is valid, the customer enters the PIN. And note that this is an interruptible region that's governed by a timeout, meaning that if the customer doesn't enter the PIN within a specific amount of time, the transaction will be canceled and the ATM will eject the card. So after the PIN is entered, the ATM sends the PIN for a validation request. The bank receives the validation request, then validates the PIN. Here's another decision. If the PIN is invalid, the ATM machine ejects the card and the customer will take the card, and this activity will end. If the PIN is valid, the customer enters the amount, the ATM sends the balance request to the bank receives the balance request, the bank reads the customer account database, which is a data store, and then checks the balance. If the funds are insufficient, the ATM adds the unsuccessful attempt to the ATM transaction details, then completes the insufficient transaction log and sends the transaction details to the bank. The bank receives the transaction details and stores it in the ATM transaction log. The ATM then ejects the card and the customer takes the card and the activity ends. If the funds are sufficient, we introduce a fork here to illustrate the activities that are happening at the same time. So here, the customer will take the money from the slot and the bank will debit the account. From there, the bank adds the successful transaction to the transaction details, then completes the transaction log and sends the transaction details to the bank. The bank receives the transaction details, stores it in the ATM transaction log, and ejects the card. From there, the customer takes the card and the activity ends. The activity diagram is one of the most popular behavioral UML diagrams because of its simplicity. To learn more about other UML diagrams, check out the playlist below, and I'll see you there. Thanks for watching.